Persona 5 Royal contains well over 200 personas, each based on mythology, literature, and history from around the world. With so many personas, I decided to do what any data scientist does, place them into arbitrary categories and compare between them. I want to examine the differences in persona stat spreads by source. That's less catchy than my last title. The first thing we need to do is get stat data from every persona. As you can see, my own collection is lacking. So rather than collect all the personas myself and manually enter their stats in, let's look to the persona community. The Megaten Fusion tool made by AQIU384 has all the information of all of the personas in the game lined up nicely. We can read the data from the website to create this table, with all the information for each persona, minus any information pertaining to skills or the persona trait system. While this gives us all the information we need pertaining to stats, we still need to record each persona's source. We can try to use the web again and automatically acquire it from the persona wiki, but this, it turns out, is not possible. Where the information on a persona's source is not always located in the same spot on the website, and for many of them the information is not even plainly listed. This leaves us stuck with one option, going through and manually researching and cataloging each persona, which I did. I actually want to go on a small tangent because I found this interesting. These 10 personas are all part of the same collection of demons called the Ars Goetia, which itself is part of the Lesser Key of Solomon, a 5-book series on demons. The details of it are pretty fascinating, so if you have a spare time to go on a Wikipedia binge, I highly recommend it. Back to Persona 5R. After manually listing persona sources, we have ourselves a CSV file that we can read into Python and add painlessly. This is the number of personas from each different region. Ugh, not a very even spread. There's only one Haitian persona, only one Spanish persona, only one Slavic one. Well, points for diversity, but the sample sizes are way too small to do any analysis on. Instead of dealing with that, let's get a way to visually display persona stats. If we're going to categorize them based on their stats, we want to be able to see them, right? Some monkeying around with Matplotlib, and now we have a nice fancy stat plotter. Now that we can see the stats, we can categorize them. Let's start with something simple, and if things go well, we can look further into it. Let's see which stats are higher than usual, or if all the stats are relatively balanced. While statistics define outliers as values more than 2 standard deviations from the mean, we don't want statistical outliers here. Why not? The answer is in Vohumana's stats. While traditional statistical analysis says there are no outliers here, RPG Brain tells us there are 2, Magic and Agi. I found the best way to identify these was to use the median plus 10% as a threshold. With all that settled, it's time to face the consequences of our own actions. The sample size for some regions is just too small. What do we do? Well, the easiest answer is to drop the groups with too few. Takes no effort, and still keeps more than 90% of personas for analysis. So with that out of the way, let's do a brief examination of the differences between groups. I do not like this. There's kind of a lot of numbers up there right now, so let's boil our problem down into something that we can explain easier. The first clue there may be an issue is the differences between means is pretty small. Aside from the huge outlier that is the gems, which seem to be P5 originals and are a special case that honestly doesn't belong in this analysis, the means are pretty similar, with a range of 0.7. The spread is also really similar between the regions, all being within the range of 0.4. At this point, we could only attempt to prove there isn't a difference between personas in different regions, which is interesting in itself, but not really what we're going for. Things look grim for our persona stat analysis, but we've got some backups. We can try looking at source type, whether a persona is from literature, mythology, history, etc. Except, they're all from mythology. Any analysis we did on this would be so heavily biased that it would be totally useless. Okay, there's gotta be something interesting here. I spent forever on this. I did manual research and data entry for hours on this. I gotta have something to show for it. Okay. We can check for differences by arcana. There are plenty of samples for each one, so we can analyze 100% of personas from the game. There are a few ways to run analysis on this type of group data. One way is to run an analysis of variance test, or ANOVA, but because of the sheer number of groups we have, this is probably not our best option. Instead, let's use a linear regression. By creating a classifier out of nothing but mutually exclusive booleans, we can see how the different arcana tend in relation to some middle. Here's the final result. The coefficient is how much higher or lower stat spreads tend to be in relation to the Chariot arcana, which has a mean 1.4 outliers. Except this isn't really a final result. We've just got a bunch of numbers. We don't even know how accurate these are. To do that, we can swap from scikit to stats models and do our job again. Hit enter, and oh, that is gross. How am I supposed to explain this in a funny YouTube video? Alright, let's just focus on this column for now, the p-value column. To be very, very reductive, This is the chance that each value is wrong. I can hear stats majors yelling at me from here. Generally, p-values of lower than 0.5 are quite nice, and p-values of greater than 0.1 indicate your data is trash. As you can see here, our data is trash! Why does this always happen? For pretty much all of our data, we can't draw any reliable conclusions about whether Arcana affects stat spread. This can't keep happening. Why does this happen? Well, one problem is the number of groups. As we have to compare between more and more groups, we need to increase the sample size of the groups. How big the sample size has to be is somewhat up for debate, but we can safely say that if your sample size within each group is less than the number of groups you have, you might have a problem. The other is we made pretty arbitrary categories. Maybe you guessed this earlier, but this is bad practice. Randomly drawing lines usually doesn't result in good data, and what data you do get is usually not very applicable. So now that you're all better data scientists than me, I've got a task for you. All the work I did on this video is available on GitHub for you to access and play with, complete with my best annotations. If you've got the time, why not try poking around? Any fellow data scientists, please feel free to use this to make your own analyses, or even your own videos. Naturally, this offer extends to people that aren't in school or in my major. You'll get to learn some stats, some Python, and some interesting fun facts about Persona 5. Going forward, unless I make a video for a class, all of my work is going to be available for you guys to use. I want to share the enjoyment I get exploring data and making videos with everyone else. I hope you find value in it. Now if you'll excuse me, my college courses start tomorrow. Hey, thanks for making it to the end of the video. I've got some more projects in the pipeline, some that are video games and data science, some that are video games without data science, and some that are data science without video games. Let me know what kind of stuff that you want to see, and if you're excited to see it, please hit that subscribe button. And if you liked this video, then please leave a like. Or if you didn't like it, leave a dislike so I can never do this again. Arkling out.